Today I'm going to be in factors and greatest common factors. This is going to be a big basis for everything we're going to be doing up for quite some time. So we're going to need to make sure that we know our factors. So we're going to work with finding those greatest common factors today, which is just a review of things that you've done in the past. So tell whether the second number is a factor of the first number. That type of question is just really saying, does 6 go into 50 evenly? And the answer is no, it doesn't. It goes in 8 times with 2 left over. So let's look at the next one here. We've got, is 7 a factor of 105? Well, we'll divide that out and see. 1, and then 7 goes into 35 5 times. So this, yes, it is a factor. Listing the factors of 28. When I list the factors, what I like to do is I like to start with 1 and then put 28 down. So we'll go from 1 to 28, then I say the next highest number, 2. Does 2 go into 28? Yes, it does, because it's even. 2 times 14 is 28. Then I say, does 3 go into 28? No. Does 4 go into 28? Yes. 4 times 7. Does 5 go into it? No. Does 6 go into it? And then I know I've filled in the gap and I haven't missed any of the factors. So this is just complete warm-up, getting ready. You should know how to do all this stuff as it is. Just a little reminder. Prime factorization is also known as a factor tree. I shouldn't say it's also known as a factor tree, but we can complete prime factorization using a factor tree. So what is a factor tree? Well, it takes a number and breaks it up into factors, and we're going to continue to break it up into factors until we have all prime numbers at the end. Prime numbers are numbers that only have factors of 1 in itself. So we're going to find the prime factorization of these two numbers. Well, it doesn't matter what you branch it off into. We could say it's 3 times 4, or we could say it's 2 times 6. We're still going to get the same answer. Now, 3 is prime, but 4 is not. So I end up getting 3 that's prime. Now I have 2 times 2. Those are both prime. I strongly urge you that you keep carrying these along so that you can see them at the end written in a row. Now I'm going to write my prime factorization as I have 2 2's, so I have 2 to the second times 3. Maybe we should write it 2 times 2 times 3, and then you can see that it's 2 squared times 3. 60. First factors that come to my mind are 10 and 6. Factors of 10 that come to my mind are 2 and 5 and 2 and 3. So I'll write these in order. 2 times 2 times 3 times 5. When I say in order from least to greatest is what I'm doing. I've got 2 of those, so that's represented by 2 squared times 3 times 5. In the next part, we're going to write the prime factorization. So I've got 40. 2 factors of 40 that come to mind are 4 and 10. 4 breaks down into 2 times 2. 10 breaks down into 2 times 5. These are all written in order, so I really can say this is 2 cubed times 5. 33. Factors of 33 are just 3 and 11, so the prime factorization would just be 3 times 11. My next example, I have 49. The factors of 49 are 7 times 7, so the prime factorization would just be 7 squared. And then lastly here, 19. 19 only has factors of 1 in itself, so the prime factorization is just plain 19.